Good morning to all of you. Welcome to Young Minds. In this session, in this class, we discuss about second year questions asked in 24th, 25, in which is conducted in the evening sheet of JEE-MAIN's examination. The first question is: Young's double-slit interference operator is immersed in a liquid of refractive index 1.44. It has slit separation of 1.5 millimeter. The slits are illuminated by a parallel beam of light whose wavelength in air is 690 nanometer. The fringe width on a screen placed behind the plane of slits at a distance of 0.72 meter will be. That means first Young's double slit experiment is performed in air. Later, whole Young's double slit interference operators are immersed in a liquid whose refractive index is what? 1.44. Actually, when you immerse the whole operators, that the separation between the slits, separation between the screen and the slits doesn't change. But what it changes? Wavelength of light is changes. Why? Because light travel from one medium to another medium. What happens? It is suffer due to change in velocity. This is called refraction of light, isn't it? So that first what is given you can write. Then you can find the fringe width. That is asking. Young's double slit interference operators is immersed in a liquid of refractive index. What is that given? Refractive index of liquid. What is that? Mu is equal to 1.44. It has a slit separation. What is that? What is the slit separation? What is that? Slit separation equal to d small d. What is that? 1.5 millimeter. Equal to what? 1.5 into 10 power minus 3 meter. Isn't it right? The slits are illuminated by a parallel beam of light whose wavelength in air. If suppose the apparatus are used while in air, what is the wavelength of light? 690 nanometer. Means what? 690 into 10 power minus 6 meter. Sorry, minus 9 nano. Minus 9. The fringe width on a screen placed behind the plane of slit distance. That means what is the fringe width? Beta is equal to what? While the screen is placed behind the plane of slits at a distance of, what is that? Capital D is equal to 0.72 meter. You know what is the fringe width? Beta is equal to what? Lambda D by D. Lambda D by D. Isn't it? Here, lambda is the wavelength of light in liquid. What is that? Liquid. L. But you know one thing. What is that? Wavelength is related to refractive index. What is that? The wavelength of light in any medium compared with the wavelength of light in air. Liquid. Medium means what? Here, liquid. That implies lambda L is equal to what? Lambda A by mu. Therefore, fringe width in fringe width of interference of Young's double slit experiment in given liquid is equal to what? Lambda L is what? Lambda A by mu into D by D. Capital D by D. That implies beta is equal to lambda A. What is the wavelength of light in water? Air. 690 into 10 power minus 9 by mu. What is the refractive index of liquid? What is it? 1.44 into capital D. The separation between slits and the screen. What is that? 0.72 meter by, what is it? Small d. What is the separation of two slits? 1.5 into 10 power minus 3. Isn't it? Here to see 0.2 times. Isn't it? So 2 3 ja, 2 4 ja, and 5. So when you take 345 by, that means 0 by 15 into 10 power minus 6, which is equal to 15 2 ja 30, isn't it? 0.23 nanometer. Yes, correct. 0.23 nanometer. This is the answer for this question. 0.23. The nanometer is the answer for this question. Right. The second question is also asked based on Young's double slit experiment. Right. In a Young's double slit experiment, 3 polarizers are kept as shown in the figure. To see, this is the first polarizer P1, this is the second polarizer P2, this is the third polarizer P3. Okay, the transmission axis of P1 and P2 are orthogonal to each other. That means the transmission axis, whenever light fall on it, both are perpendicular, orthogonal to each other. Okay, the polarizer P3 covers both the slits. This is the polarizer P3 covers both the slits. Okay, which is with its transmission axis is what, at 45 degrees of P1 and P2, and unpolarized light of wavelength lambda and intensity lambda I naught. That means wavelength lambda and intensity what, I naught, is incident on P1 and P2. The intensity at a point after P3, intensity at a point after P3, where the path difference between the light waves from S1 and S2 is what, lambda by 3 is. What is the intensity? Suppose after passing, what happened, both the light waves are arrived a common point P on the screen, which is kept behind the P3. Okay, they are arrived some phase angle. So at that point, what is the intensity is asking. Okay, to solve this problem, some analysis is required. To see, this is the first slit. Okay, this is the first polarizer P1, where light is incident of wavelength lambda and intensity I naught. Okay, what happened, the transmitted light intensity equal to what, half, that means I naught by 2. Similarly, second polarizer P2 is also made incident wavelength lambda and intensity I naught, the transmitted light intensity equal to what, I naught by 2. Okay, now these two are passing through what, slits S1 and S2. What happened, again these are passes through what is the third polarizer P3, third polarizer what, P3. Okay, the lights emitting from S1, slit S1 and S2 passes through third polarizer what, P3. This is called as an analyzer. According to Malus law, whenever polarized light passing through an analyzer, the transmitted light from the analyzer intensity becomes cos square times of intensity of light incident on this analyzer. That means what, the coming intensity of light from this analyzer, that means polarizer P3, equal to what, I naught by 2 cos square theta. Okay, here the actually what is given, this is analyzer P3, the polarizer P3 covers both the slits with its transmission axis what, 45 degree. Here theta equal to what, 45 degree. Therefore, intensity of light from slit S1 equal to what, from Malus law, I naught by 2 cos square 45. Therefore, I1 equal to what, I naught by 2 into 1 by root 2 whole square, because cos square theta. Therefore, I1 equal to what, I naught by 4. Similarly, second coherent source is also passing through this analyzer. So, the transmitted light intensity, what is the, I naught by 2 cos square theta. Okay, so it is also theta equal to what, 5. So, I1 is equal to what, I2. So, I1 I2 both are same intensity. What is that, I naught by 4. What is that, I naught by 4. Okay, now you want to calculate what happened. So, after passing through this analyzer, both the light waves are arrived common point P on the screen, which is kept behind the P3, that means polarizer P3, that is given in this question. Arrive a common point on this screen, which is kept behind the polarizer P3. Okay, arrive with what angle? That is called phase difference. That is called what I say, phase difference delta. Okay, but path difference is given. What is the path difference? What is that? Both are arrived lambda by 3. Lambda by 3. So, the resultant intensity at this point is asking. Okay, so to see that one we can do like this way. What is the resultant intensity in interference pattern? what is that? I is equal to root over I1 square plus I2 square plus 2 I1 I2 cos phi, isn't it? Here I1 is equal to I2 is equal to what? I0 by 4, but we don't know the phase angle. So, from relation between path difference and phase difference, path difference and phase difference, path difference and phase difference are related like what is that? Phi, phase angle, phase difference, phi is equal to 2 pi by lambda into path difference delta x. Here path difference is given, what is that? Lambda by 3. Therefore, phase difference delta, that means phi or phi, whatever may be it you may use, phi is equal to 2 pi by lambda into what? Lambda by 3. So, this lambda cancel, what is the angle? Phase difference 2 pi by 3. So, net resultant at this common point P after arriving from S1 and S2 and passing through the polarizer P3 is equal to, what is it? I0 by 4 whole square plus I0 by 4 whole square plus 2 I0 by 4 into I0 by 4 into cos square, what is that? 2 pi by 3. Okay, when you solve this one, finally get what? I0 by 4. So, this is the net resultant intensity while two coherent sources arrive this common point P is equal to what? I0 by 4, that is required. Okay, right. The third question, the ratio of the power of a light source S1 to that light source S2 is 2. That means, what is given? Power, the ratio of the power of light source P1 by P2 equal to what? 2 is given. Okay, right. 2. S1 is emitted 2 into 10 power 15 number of photons per second at 600 nanometer. So, from source S1, from source what? S1, the number of photons emitted N1 equal to what? 2 into 10 power 15. Okay. Moreover, the wavelength of light is lambda 1 equal to what? 600 nanometer, isn't it? Right. If the wavelength of source S2, that means from S2, source S2, the emitted, okay, N2 as well as lambda 2, what is that? If the wavelength of source S2 is what? 300 nanometer, then the number of photons per second emitted S2 is how much? N2 is equal to what? Okay. First of all, how related power with number of photons emitted. So, to see from definition of power, what is the power? Okay, emitted by a source, power emitted by a source of light, by a source of light. Okay, P is equal to, what is that? Energy of photon, energy of photon into number of photons, number of photons, okay, per second. What is that? That means every source, suppose this is a source that emits energy in the form of what? Photons, emitted in the form of what? Photons. So, each photon having energy is equal to what? E is equal to h nu, number of photons equal to what? N. So, therefore, P is equal to energy of each photon is equal to what? H nu, okay, into N by T, okay, H nu into what? N by T. But nu is equal to what? Frequency is not given in term, frequency may be right in terms of wavelength. What is that? Hc by lambda 1, Hc by lambda into N by T. Okay. Therefore, P1 by P2 is equal to Hc by lambda 1 into N1 by T into T by Hc by lambda 2 into N2. You know, Hc by lambda is cancelled, T is also cancelled. That implies P1 by P2 is equal to N1 by N2 into lambda 2 by lambda 1, isn't it? Yes, correct. That implies P1 by P2 is given, what is that? 2. That implies 2 is equal to N1. N1 is what? 2 into 10 power 15 by N2 into lambda 2, what is given? 300 nanometer. 300 by lambda 1, 600 nanometer. Okay, all right. So this one, the 2 ja, this 2 is also cancelled, isn't it? That implies N2 is equal to, what is the value? 1 by 2 into 10 power 15, 0.5 into 10 power 15. Okay, this number of photons are emitted. Okay, okay, from that means what? It is simply cycle. Therefore N2 is equal to 5 into 10 power 14 number of. Okay, so N2 is equal to 5 into, so the answer will becomes what? 5. Okay, that's it. The fourth question, arrange the following in the ascending order of wavelength. To see, from some waves are given, but you can remember exact order. What is that? From spectrum of EM spectrum, electromagnetic wave spectrum, electromagnetic wave spectrum. What you know one thing, the gamma rays have the least, okay, distance are supposed to be travel. Okay, so these are very short range, that means short distance travel, gamma rays. Next one is called X-rays. Okay, next one is called UV rays, ultraviolet rays. Next one is called visible. Okay, next one is called infrared. Infrared, this is the gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays. Okay, next one is called microwave. Last one is called radio waves. This is the exact order of, okay, wavelength, increasing order of wavelength. While you take along this way, this is a increasing range of what? Frequency along this side. Okay, you know, gamma rays, X-rays, UV rays, visible, infrared, micro and radio waves. These are the, this is the ascending order of what? Increasing wavelength. That's why radio waves are sent for getting the signals from long distances from by using the artificial satellites, and that means we can use the communication generally. So these are very long range, then after microwave, then after infrared, like this. So what is asking, arrange the following ascending order in the wavelength. According to, when you come to this question, to see microwaves, where is the microwaves? This is the, these are the highest range, isn't it? That means lambda 1. Okay, next one is called ultraviolet, UV rays. Their wavelength is lambda 2. Their wavelength is what? Lambda 2. Okay, right. Next one is what? Infrared. Infrared is supposed to see, microwaves are what? Lambda 1. Ultraviolet, these are lambda 2. Infrared is lambda 3. X-rays are lambda 4. So while you writing ascending order, lambda 4 is the least one, then after lambda 2, then after lambda 3, then after lambda 1. So this is the answer for this question. Okay, right. Right, the fifth question, in photoelectric effect, the stopping potential versus frequency curve is plotted. Based on that one, some points are given. From this you should choose the correct one. Okay, you know, in photoelectric effect, from Einstein photoelectric equation, the instant radiation, that means h nu is equal to work function plus kinetic energy. Energy of instant radiation is utilized for some doing work to eject electrons, and remaining is converted into kinetic energy of emitted photons. That implies h nu is equal to work function is equal to what? H nu naught plus k. So, the kinetic energy of ejected electrons is depends on stopping potential that you should connected across the collector and emitter. Okay, that implies h nu is equal to h nu naught plus k max equal to what? E into V naught. Here V naught is the stopping potential. Okay, so when you draw graph between stopping potential and frequency, okay, stopping potential and frequency, this is the frequency of instant radiation and this is the stopping potential. You should get a graph like this. So, here this is equal to what? Threshold frequency. From this one you should come to one conclusion, the instant radiation having sufficient minimum frequency, otherwise there is no photoelectrons are ejected. So, from this one you should write nu is equal to what? H nu, okay, here nu is equal to C by lambda, isn't it? So, from this one you can write E V naught is equal to h nu minus h nu naught. That implies stopping potential nu is equal to what? H by E into nu minus h by E into what? Nu naught, isn't it? V naught is equal to what? H by E into nu minus h by E into nu naught. So, when you draw a plot between stopping potential and frequency, what is the relation? Here h by E is a constant, therefore, stopping potential is directly proportional to nu, because h by E is equal to what? Constant. So, stopping potential and frequency relation, that means frequency relation is what is that? Linear impedance. So, first option is correct. The relation between stopping potential and frequency is linear, right. The slope of V naught versus nu curve is equal to phi by h, worked function by h. So, it is not correct. Okay, why? Because here slope is equal to what? H by E, slope equal to what? H by E, because it is a constant. So, from this one you get a slope, it is nothing but what is that? H by E. So, it is not correct. Okay, h constant is related to the slope of V naught. Yes, from this one you get the what is the value? Slope, what is it? The constant h constant is related to slope, isn't it? Right. So, this is correct. The value of electric charge of electron is not required to determine h using the nu naught versus nu, but it is not correct. Why? Because we can must depends on E value, then only get okay, h value, Planck's constant. You know the stopping potential, you know the frequency of instant radiation, and you know the frequency charge of the electron, then you get the value of h. Okay. So, the value of electric charge of electron is not required. Oh, it is not wrong, it is required, to determine the h value from nu naught versus frequency versus stopping potential. And next, the work function can be estimated without knowing the value of h. You know, you want to calculate work function is equal to what? H nu naught equal to what? H C by lambda. So, while you are calculating work function, you must having h value, otherwise it is not possible. So, it is also not wrong, sorry, it is okay, can be estimated without knowing. So, it is not with knowing, so it is also right. So, from this option you know what? A, C, E are the correct options for this question. Okay, right. Okay, the sixth question. A photograph of a landscape is captured by a drone camera of height h. How much? 18 km. That means height of the drone camera. Height of the drone camera equal to what? 18 km. That means what? Suppose this is a drone camera. It is somewhat height h above the ground. Okay, right. This is equal to what? 18 km height. The size of the camera film is what? 2 into 2. Size of camera film. Size of camera film. 2 into 2 centimeter square means what? 4 into 10 power minus 2 means square, that means minus 4 meter square. And area of the landscape area. Okay, so what happened? Suppose this is a film of a drone camera. It captured some area. What is the area it is supposed to be captured? Area of landscape. Landscape that is photographed by this drone camera. What is that? 400 kilometer square. That means what? 400 into 10 power 6 meter square. Okay, so that means what? This is the one end is captured, this end of this landscape, this end of the drone camera is supposed to be captured, this end of this landscape. Total area of the landscape is equal to what? 400 kilometer. So what happened? This is theta, this is also equal to theta. So what happened? Suppose this is x, this is y, sorry, this is x or this is whatever maybe you can take. This is x and what? This is y. So what is that? This is the half means what? 20 into 10 cube. Okay, this area equal to what? 2 into 2 centimeter square. Okay, this is equal to 400 into 400 kilometer. Okay, so the focal length, what is asking? What is the focal length of this drone camera? Focal length of drone camera f is equal to y. So what is that? You know, x by y or y by x, whatever maybe you can take. What is that? X by y is equal to this height to this height, isn't it? This point is, that means total height f, that means 18 kilometer by focal length f. Okay, so here what is the x value? 20 into 10 cube, isn't it? 20 into 10 cube. Why? Because 400 is equal to what? 20 into 20 is equal to 400. Okay, kilometer 10 power 6 means what? 20 into 10 power cube, that means 20 into 10 cube by what is that? 2 into 10 power minus 2, isn't it? Is equal to 18 kilometer. That means kilometer means what? 18 into 10 power 3 by focal length f. That implies f is equal to 36 into 10 power 1 by 20 into 10 cube. Okay, that means we get to 1 ja to 1.8, that means 8 into 2 ja 28, that means 1.8 centimeter. Okay, this is the answer for this question, right? Okay, the seventh question. A small uncharged conducting sphere is placed in contact with identical sphere but having 4 into 10 power minus 8 coulomb charge and then removed to a distance such that the force of repulsion between them is 9 into 10 power minus 3 Newton. The distance between them is, so what is given? A small uncharged conducting sphere. Suppose this is a small uncharged conducting sphere. So what is the charge on its surface? 0. Okay, which is in contact, placed in contact with an identical sphere, which is in contact with the identical sphere having charge 4 into 10 power minus 8 coulomb. Okay, and then removed. So whenever you contact a charged sphere to an uncharged sphere, charge is what? Distributed equally. That means what? After what happened? Each thing, that means each one having, okay, share their charge. What is that? Q by 2 and then what? Q by 2. That means the charge on this first sphere is equal to 2 into 10 power minus 4 coulomb and charge on it is equal to 2 into 10 power minus 4 coulomb of same kind. Okay, so what happened? So what happened? Both are repelled to each other. So what happened? Now these two spheres are kept somewhat distance. How much distance they are separated? By means of acting force F is equal to what? 9 into 10 power minus 3 Newton. Okay, that means while you are kept these two charges at a distance of how much? Then the force existing between them is equal to this much. So what is the distance? So from Coulomb's law, what is that? Force of repulsion or attraction between charges is equal to 1 by 4 pi epsilon naught into q1 q2 by r square. You know, f is given, what is that, 9 into 10 power minus 3 is equal to 1 by 4 pi epsilon equal to what, 9 into 10 power 9, what is that, 9 into 10 power 9 in SI units, okay, into q by 2, q1 equal to what, after contact these two, what is the charge resides on each, that is equally distributed. What is the q by 2 means what, 2 into 10 power minus 4, okay, into q2 is also 2 into 10 power minus 4 by r square. So, on both sides this 9 is cancelled. So, what is the 10 power minus 3 is equal to 2 ja 4 into 10 power 1 10 by r square. That implies r square is equal to 4 into 10 by 10 cube, that will equal what, 4 into 10 power 4, that implies r is equal to what, 2 into 10 square, okay, meter, that implies equal to what, 2 centimeter in centimeters. What is that, 2 centimeter, that is it. This is the answer for this question, okay, right. Right, the 8th question, in first config, this is configuration 1, this is configuration 2, okay. In the first configuration 1, as shown in the figure, 4 identical charges, what is that, q naught, are kept at the corners of A, B, C and D of the square of side A. This is a square, of side is what, A, okay. On its 4 corners, a charge of magnitude q naught is kept, okay, right. Next, in the second configuration 2, the same charges are shifted to their midpoints. Suppose now, earlier the charge is here, now it is shifted to here, that means what, charge q naught, q naught, q naught and q naught, okay, right. EFGH square, if k is equal to 1 by 4 pi epsilon naught, the difference between the potential energy of configuration 2 and 1 is, to see, in first configuration, okay, what is that, potential energy of system of 2 charges, is equal to u is equal to what, 1 by 4 pi epsilon naught q1 q2 by r, q1 q2 by r. This is the definition of what is that, potential energy of a system of charges. Whenever 2 charges, the work done to make a system of 2 charges, okay, is stored in the form of potential energy. So, u is equal to what, 1 by 4 pi epsilon naught q1 q2 by r square. Here both the charges are same. So, what is that, k is equal to what, 1 by 4 pi epsilon naught equal to what, k into q naught square by r. This is the potential energy of 2 charges placed at AB at distance A. So, what is the value, okay, right, BC, CD and DA. Similarly, okay, this is the system E, that means D and B is also at some distance, A and C also some distance. So, total charges, system of charges, how many combinations are there? There are 6 combinations. So, what is the total potential energy contributed at this point A O? Therefore, U1 is due to first one equal to what, K q naught by r square. Like this, how many charges are there? That means how many systems are there? AB is 1, BC is 1, CD is 1 and DI is 1. So, that there are 4 plus, moreover BD and AC is also another system of 2 charges. There are contributes energy at point O. So, what is that, k q naught by, here side is equal to A. So, it is equal to what, A square in place of A, sorry, A, only A, k q naught by A into what, 4 plus k q naught by A into the distance between these two, this is a square thing about root 2, what is that, root 2 into A. So, what is its value into distance 1 by root 2, isn't it? How many are there? 2 are there. So, 2 into. So from this one you can take KQ A by common, KQ naught by A equal to what? 4 plus this is root 2 into root 2, 1 root 2 cancel, 4 plus root 2, this is 1. Potential energy of first configuration is equal to this thing. Okay, right. Next, potential energy of second system of potential energy of in second configuration, in second configuration, in second configuration. What is that? Potential energy of system U2 is equal to, how many are there to say? These two are how much distance? This is the distance, this is the distance, this is the distance between them, this is the distance between them. These two are at a distance of something. These two are contribute some energy, isn't it? Okay, which is equal to what? K Q naught square, here, K Q naught square, Q into Q, Q naught, that means K Q naught square, that means right, K Q naught square by distance between them, which is obtained by formula. The distance is equal to what? This is A by 2, this is A by 2, this is what? Root 2 A by 2, that means what? Root 2, that means A by root 2, 1 by root 2 into A, that means A by root 2. Okay, like that 4 plus remaining 2 are there. What is that? EF, HF and EG, okay, which is also contribute, isn't it? So when you take this K Q naught variable to common, that means what? 4 plus 4 root 2 plus 2, this is the you get potential of this system. So what is asking? Therefore U2 minus U1, you are doing what? U2, that means what is asking? The difference between the potential energy of configuration 2 and 1 is U2 minus U1 is equal to, what is that? K Q naught square by you should supposed to be taken, okay, then remaining you get 3 root 2, while doing you get this value 3 root 2 minus 2. Okay, so this is the answer for this question. Okay, right. Okay, the ninth question. A tightly wound long solenoid carries a current of 1.5 ampere. An electron is executing uniform circular motion inside the solenoid with a time period of 7 nanoseconds. The number of turns per meter in the solenoid is, okay, to see. What is given? A tightly wound solenoid. Suppose this is a tightly wound solenoid, okay, carries current. The current carries this solenoid I is equal to 1.5 ampere. An electron is executing uniform circular motion inside the solenoid. That means whenever current passing through the solenoid, what happened? A magnetic field is set up, isn't it? In this magnetic field, an electron is executing uniform circular motion inside the solenoid with the time period T is equal to what? 7 nanosecond, means what? 10 power minus 9 nano. Okay, 10 power minus 9 second. Okay, right. The number of turns per meter in the solenoid. So the number of turns in the solenoid equal to what? This is asking. How we can do this question? We know very well, due to solenoid, what happened? Magnetic field is set up. What is it? Due to solenoid, okay, magnetic field produced due to current carrying inside it. Magnetic field B equal to what? Mu naught into N into I. You know very well this formula. Mu naught is the permeability, N is the number of turns in the coil, and I is the current carrying. This is you want to calculate. Okay, so in this magnetic field, what happened? An electron is executing, so it is moving in circular path. So you know very well, any electron enter into a magnetic field, that field experience force on it. So due to that force, the electron is executing in circular path, isn't it? So the necessary centripetal force provided to executing electron due to this magnetic field. So therefore magnetic field, okay, necessary to provide centripetal force mv squared by r equal to what? Fb is equal to mv squared by r. Here Fb, magnetic force, is equal to what? Q into V into B, QVB, from Lorentz force, isn't it? Therefore QVB is equal to mv square by r. On both sides 1v is cancelled. That implies r, radius of the circular path execute, okay, by an electron due to this magnetic field produced by this solenoid carrying current sum. R equal to what? R equal to mv by q into b. R is equal to mv by q into b. Here what happened? The solenoid, in this solenoid, electron is executing circular path. So the time period of that electron is given. Here time period t is equal to what? 2 pi r by v. From definition of velocity is equal to displacement by time, and time is equal to what? 2 pi r by v. That implies t is equal to 2 pi r equal to what? M v by q b into v. So this v is also cancelled. That implies time period t is equal to what? 2 pi m by q into b, isn't it? Now you should calculate n value, but b is equal to what? But b is equal to b naught into ni. That implies t is equal to what? 2 pi m by q into mu naught into n into I. You required n, that implies n is equal to what? 2 pi m by q into mu naught into t into I. Now substitute all the values. Therefore n is equal to 2 pi into m is the mass of the electron, equal to what? 9 into 10 power minus 31 by q, charge of the electron, 1.6 into 10 power minus 19 into mu naught equal to what? 4 pi into 10 power minus 7. This is a constant value, you know very well. T, time period given, what is that? 7 into 10 power minus 9 second into current I is equal to what? 1.5 ampere. Okay, this 2 pi, this 2 times. When you're doing this one, finally you get answer equal to what? 250. What is that? 250. This is the answer for this question. So this solenoid containing what? 250 number of turns. Okay, right. The 10th question. N equally spaced charges, each of value q, are placed on a circle of radius r. What is that? To see, this is a circle of radius is r. On this circle there are charges, equal charges, q, 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 like that, n number, okay, are placed. What happened? The circle rotates about its own axis. Suppose this is the circle, rotate about its own axis. It is in horizontal, okay, with an angular velocity omega as shown in the figure. Okay, right. This is rotate. So what happened? It constitutes current. Okay, so current due to circle A is equal to A. Next, what happened? A bigger Amperian loop B. Suppose this is the bigger Amperian loop B, encloses the whole circle as similar Amperian loop A, encloses a small segment. Suppose this whole circle, that means Amperian loop A, is encloses by bigger Amperian loop B, which is enclosed only small part. Okay, what happened? That's it. This is given. The difference between enclosed currents IA, current due to Amperian loop A, and current due to Amperian loop B. So what is the difference between these two currents? Okay, for the given Amperian loop is. Or understand? Once again I would like to explain. N equal, suppose to see, this is a big Amperian loop. Okay, its radius is what? R. Okay, on this Amperian loop there are n number of charges are supposed to be kept. Along with the loop, what happened? These charges also rotate about an axis called axis of this big Amperian loop A with an angular velocity what? Omega. Okay, so current due to what happened when charges are moving, current is produced. So current due to okay Amperian loop, current due to Amperian loop, okay, A is IA is equal to what? Generally formula is equal to what? Q by T when one charge is moving. But here in this Amperian loop, how many charges are there? N charges are there. So N into Q by T. This is the current due to first Amperian loop having N number of turns. Okay, here to see, this is the Amperian loop is rotate about its own axis with an angular velocity omega. So its time period equal to what? 2 pi by omega. Therefore current due to big Amperian loop A having N number of charges rotate about its axis with angular velocity omega. So IA is equal to what? N into Q into 2 pi by omega, which is equal to what? N into Q into omega by 2 pi. This is the current due to big Amperian loop in terms of charge, its angular velocity, and having N number of turns. Now this is the Amperian loop carrying current I is enclosed by another Amperian loop B. It doesn't have any charges. So current due to Amperian loop B is IB equal to what? 0. Isn't it? It doesn't have any charges. Therefore required IA minus IB. This is asking the difference between the enclosed currents IA minus IB is equal to IA equal to what? N into Q into omega by 2 pi minus 0. So answer equal to what? N into Q into omega by 2 pi. Okay, this is the answer for this question. Okay, right. The 11th question, assertion and reason type. What is given to see? Assertion here. A electron in a certain region of uniform magnetic field is moving with constant velocity on a straight line path. What happened? Electron in a certain region of uniform magnetic field is moving with constant velocity in a straight line path. Okay, so this is a uniform magnetic field. In this uniform magnetic field, an electron is supposed to be moving, okay, in a straight line path. This is suppose this is a magnetic field. An electron is moving in this magnetic field with constant velocity. You may define like this way or like this way. What is you may interest, no problem. So any charged particle moving in uniform magnetic field, it experiences okay force. That is force is called Lorentz force. So force acting on a charged particle in uniform magnetic field. Uniform magnetic field is Lorentz force. FB is equal to what? Q into V bar cross B bar, which is equal to what? F is equal to QVB sin theta. Okay, right. The magnetic field, this is the assertion. Electron in a certain region of uniform magnetic field is moving with constant velocity in a straight line path. It may be correct. Yes, it may be correct according to this one, because it is experiences a force, continuous force. So it is moving in a particular path. It is depends on in what path, in what way, with what angle with which it is supposed to be entered with respect to the magnetic field. So it is correct. Next reason, the magnetic field in that region is along the direction of velocity of the electron. What What is the magnetic field in that region is along the direction. That means given theta is equal to what? 0 degree. That implies FB is equal to what? QVB into sine 0. You know sine 0 equal to what? 0. 0 into something equal to 0. So electron may be entered into along the path of magnetic field, then it doesn't experiences any force. Okay, right. If theta is equal to 180 degree, FB is equal to what? QVB into sine 180. Sine 180 is also equal to 0. 0 into something equal to 0. So the electron may be moving in the direction or opposite direction, whatever may be it. It doesn't experience any force. So what happened? Reason. The magnetic field in that region is along the direction of velocity of the electron. Yes, it is also correct. That means what? Velocity of the electron and magnetic field both are parallel to each other. Okay, right. So assertion is correct, reason is correct. Reason is the correct explanation of assertion. Okay, this is the answer for this question. Okay, right. Right. The 11th question, assertion and reason type. What is given to see? Assertion here. A electron in a certain region of uniform magnetic field is moving with constant velocity on a straight line path. What happened? Electron in a certain region of uniform magnetic field is moving with constant velocity in a straight line path. Okay, so this is a uniform magnetic field. In this uniform magnetic field, an electron is supposed to be moving, okay, in a straight line path. This is a magnetic field. An electron is moving in this magnetic field with constant velocity. You may define like this way or like this way. What is you may interest, no problem. So any charged particle moving in uniform magnetic field, it experiences force. That force is called Lorentz force. So force acting on a charged particle in uniform magnetic field. Uniform magnetic field is Lorentz force. FB is equal to what? Q into B bar cross B bar, which is equal to what? F is equal to QVB sine theta. Okay, right. The magnetic field, this is the assertion. Electron in a certain region of uniform magnetic field is moving with constant velocity in a straight line path. It may be correct. Yes, it may be correct according to this one, because it is experiences a force, continuous force. So it is moving in a particular path. It depends on in what path, in what way, with what angle with which it is supposed to be entered with respect to the magnetic field. So it is correct. Next reason, the magnetic field in that region is along the direction of velocity of the electron. What is the magnetic field in that region is along the direction. That means given theta is equal to what? 0 degree. That implies FB is equal to what? QVB into sine 0. You know sine 0 equal to what? 0. 0 into something equal to 0. So electron may be entered into along the path of magnetic field, then it doesn't experiences any force. Okay, right. If theta is equal to 180 degree, FB is equal to what? QVB into sine 180. Sine 180 is also equal to 0. 0 into something equal to 0. So the electron may be moving in the direction or opposite direction, whatever may be it. It doesn't experience any force. So what happened? Reason. The magnetic field in that region is along the direction of velocity of the electron. Yes, it is also correct. That means what? Velocity of the electron and magnetic field both are parallel to each other. Okay, right. So assertion is correct, reason is correct. Reason is the correct explanation of assertion. Okay, this is the answer for this question. Okay, right.